Hello, today we will discuss the frequency response and impulse response of discrete time system. Till now we discussed the DTFT of a signal. Now we are going to discuss the DTFT of a system. We know, assume it is a discrete time system. Its response is h of n, input is x of n, output is y of n. Now the y of n equal to x of n convolutional with h of n. If I apply Fourier transform on both sides, then y of n will become y of e power j omega, x of n will become x of e power j omega. This convolution will become multiplication into h of e power j omega. From this one, h of e power j omega is nothing but y of e power j omega by x of e power j omega. This h of e power j omega we can call as a frequency response or transfer function or system response. We will see some problems on frequency response and impulse response. Consider a causal stable LT system whose input is x of n and output is y of n related by a second order difference equation. Because system is discrete system, the equation is called a difference equation but not differential equation. They are asking determine frequency response, transfer function, or we can take it as a system response also. Second one, they are asking impulse response. We will say one by one. The given difference equation is this one. Take Fourier transform on both sides, then y of n will become y of e power j omega minus 1 by 6 constant as it is. If I apply Fourier transform for y of n minus 1, this minus 1 will become e power minus j omega y of e power j omega minus 1 by 6 y of n minus 2. This minus 2 will become e power minus 2 j omega, then y of e power j omega. Fourier transform of x of n is x of e power j omega. Take y of j omega, y of e power j omega common factor, then y of e power j omega into x of e power j omega. So first question they asked frequency response equal to h of e power j omega, that equal to y of e power j omega by x of e power j omega. Now take this x of e power j omega to the left side, send this multiplication factor to the right side, you will get this one. This is nothing but frequency response. Second question they are asking impulse response. If it is an impulse response, the impulse response always in terms of time domain, that means h of n, sequence h of n. To get h of n, we have to apply inverse Fourier transform for h of e power j omega. But h of e power j omega is available here. H of e power j omega equal to this one. If you take inverse Fourier transform for this equation, you will get a h of n. So before applying inverse Fourier transform, the denominator is a second order. You have to convert into simple pole, then apply partial fractions, then apply inverse Laplace, you will get a h of n. We will say one by one. H of e power j omega is equal to this one. Take LCM, e power minus j omega will become 1 by e power plus j omega. E power minus 2 j omega will become 1 by e power 2 j omega. If you take LCM, the numerator will be e power 2 j omega over e power 2 j omega minus 1 by 6 equal this one. So always if it is a Z transform or DTFT, always try to convert the numerator part as a e power j omega into e power j omega. If it is e power 3 j omega, that will become e power j omega into e power 2 j omega. Anyway, you split e power 2 j omega as a e power j omega into e power j omega. Bases are equal. When add the power, you get the same thing. Now I am taking e power 1 e power j omega to the left side. Why I am taking e power j omega to the left side? At the end of the result, we will know. So this e power j omega to the left side, then remaining one is e power j omega. This one. Now it is a second order. I am going to convert in terms of partial fractions. So to get otherwise in terms of a simple pole, to get the second order in terms of simple pole, if you multiply two number, I want minus 1 by 6. If you add the same number, I want minus 1 by 6. Then what is the factor? Take this minus 1 by 6 as it is. Multiply two number, I want minus 1 by 6. Add the same number, this is the addition symbol, I want this minus 1 by 6. Factors are minus 1 by 2 plus 1 by 3. Take minus 1 by 2 plus 1 by 3 and add to the numerator as it is e power j omega as it is. Add to e power j omega minus 1 by 2. That factor is minus 1 by 2. This plus 1 by 3 add to e power j omega plus 1 by 3. Now you can apply partial fractions. So e power j omega over e power j omega minus 1 by 2, e power j omega plus 1 by 3, that equal to a by this one plus b by this one. To find a value, a equal to the denominator of a is this one. You remove e power j omega minus 1 by 2 from the original one, then remain 1 e power j omega over e power j omega plus 1 by 3. At e power j omega minus 1 by 2 is equal to 0. This is the denominator of a. Now e power j omega equal to 1 by 2. Put e power j omega equal to 1 by 2 in this equation, you will get a value. So a equal to 3 by 5. The same way b equal to the denominator b is e power j omega plus 1 by 3. You remove this one from the original one. The remaining one is e power j omega over e power j omega minus 1 by 2. At e power j omega plus 1 by 3 equal to 0, then e power j omega equal to minus 1 by 3. Put e power j omega equal to minus 1 by 3 in this equation, then you will get b value. B equal to 2 5. Now replace a value, b value here. Then h of e power j omega by e power j omega is equal to 3 by 5 a value plus b value 2 by 5. Now I am going to send this e power j omega to the right side. Now you know what is the purpose of taking e power j omega to the left side. Okay. Now I am going to send this e power j omega to the right side. It will become 3 by 5 e power j omega plus 2 by 5 e power j omega. Now the denominator take e power j omega is a common factor here and here also. Then e power j omega gets cancelled, j omega gets cancelled. To make a cancellation of e power j omega, I have taken e power j omega to the left side. Now next step we will see 3 by 5, 1 by 1 minus 1 by 2 e power minus j omega. 1 by 1 minus, it is a plus. Now I am going to write this plus as a minus of minus 1 by 3 e power minus j omega. We studied at the starting the Fourier transform of a power n u of n is equal to 1 by 1 minus a e power minus j. Compare this one with the standard formula, then you will get this 1 by 1 minus 1 by 2 e power minus j omega. That means if I apply inverse Fourier transform for this equation, h of e power j omega will become h of n 3 by 5 as it is. If I apply inverse Fourier transform for this one, you will get always it is 1 minus, it is 1 minus now 1 by 2 whole power n u of n plus 2 by 5 as it is 1 by 1 minus a value is minus 1 by 3 whole power. This is the impulse response. Last problem we will see. Evaluate the following integral. This question is based on the Parseval's theorem. We know Parseval's theorem, the energy density is equal to 1 by 2 pi dl minus by 2 pi mod capital X of e power j omega whole square d omega. Now send this 2 pi to the left side, you will get this one. Now this x of n, if I apply Fourier transform only for this x of n, that equal to x of e power j omega. Compare this result with the given question, then x of e power j omega is equal to 1 by 1 minus 1 by 4 e power minus j omega. If I apply inverse Fourier transform for this one, we will get x of n equal to 1 by 4 whole power n u of n. So this is the question they asked. Integral minus by 2 pi mod x of e power j omega whole square d omega equal to 2 pi summation equal to minus into plus infinity. The given signal x of n as 1 by 4 whole power n u of n whole square. Because of this u of n, minus it will become 0. That means u of n value equal to 1 from 0 to infinity. 1 by 4 whole power n whole square. Now interchange these two. Take this 2 inside, take this n outside. 2 pi into summation n equal to 0 to infinity 1 by 4 square, that means 16 whole square. Convert into standard formula. 2 pi into summation n equal to 0 to infinity something power n that equal to 2 pi into first term divided by 1 minus second term by first term. You will get 32 pi divided by 15. Thank you.